Thank you very much for the introduction. Yeah, so today I want to clear things up a little bit around contract testing and why maybe it's a bad idea to do end-to-end tests and why it might be a good idea to actually stop doing them. Okay, so in this talk, first of all, we want to look at why end-to-end tests do not work with microservices, at least in my opinion. Second, we also will take a close look at one of the alternatives for testing, which is mocking, or for alternatives for end-to-end testing, which is mocking, and why using mocks for testing can lead to false confidence. And last but not least, the main topic of today will be how we can test server-side rendered applications, or particularly server-side rendered applications like Next.js and Nuxt.js powered applications using contract testing techniques. But let's start with contradicting myself. Let's start with the statement that end-to-end testing actually is fine, or at least can be fine, as long as we are working on monolithic applications opposed to applications in a microservices context, for example. So when your application looks something like you can see here, so you have a single application getting all its data from a single database or maybe even multiple databases. But as long as there are no microservices powering your application, then actually we can use database seeding, for example, to get our database in a particular state. And with a setup like this, actually end-to-end testing isn't that bad. So actually, if you're using a setup like this, you're probably good with end-to-end tests too, with modern tools like Playwright and so on. But as I already hinted at, with microservices, actually everything changes, because with microservices, if our architecture looks something like you can see here, if you have one or multiple applications talking to multiple services, getting the data over HTTP, so those applications can be web applications, this can be a mix of web applications and native desktop and mobile applications and so on. And all of those applications get the data from dozens, maybe even hundreds or thousands of microservices, where each microservice gets its data from its own database. In an architecture like this, in an environment like this, end-to-end testing actually is a pretty bad idea, I think. So I urge you to don't do end-to-end testing when you are doing microservices. But why do I think it's such a bad idea to use end-to-end tests for microservices? So first of all, end-to-end tests, especially in a microservices environment, very quickly become slow and flaky because you have so many different services you have to connect to. And especially in testing environments, you maybe have underpowered machines powering those microservices, and things can get slow. And because it's also not that important that all the services run all the time in a test environment, maybe they sometimes don't run, and then your tests are flaky for your application. And yeah, those services may be unavailable or unstable during testing because, it's a test environment and maybe things aren't as well maintained there as on production. But even more importantly, testing across multiple service boundaries is actually a very complex thing to do, because when you are testing your application, you have a couple of scenarios you want to test. So you want to make sure that your application in a particular scenario behaves exactly like you want it to behave. And for this, you need a defined state. You need particular data coming back from those services. And this is actually a pretty hard thing to do. So if you need exactly some data, a particular data set for one scenario, then you need some way to control the service to actually deliver these data, and this isn't an easy thing to do, or sometimes it's even impossible to set up your environment to do stuff like that. And because all of that, I think that end-to-end tests actually prevent independent deployment of your microservices. And this is actually the most important reason why you want to split up your application into multiple services, so you have independent units, independent deployable units. And with end-to-end tests, you kind of defeat the point, because if you rely on end-to-end testing to ensure that your application in a microservices environment still works, then basically your application isn't independently deployable anymore. So if end-to-end testing isn't a good idea for determining whether our application really works before deploying it to production, then what about mocking? Can we actually use mocking to test our applications when we are using microservices? So what I mean by that, by using mocking, is that when we are testing our application, during the test, we mock all the requests to all the microservices we need for our application to run, so that we don't rely on the actual services running anymore, but we have static mock data. So for example, when we are using a tool like Playwright, we might have a simple test like you can see here. We say it should be possible to remove an item. We will later see a simple shopping list application where we can add items to the shopping list and remove items from a shopping list. And if we want to test that, then we might have a test like you can see here with the Playwright route feature, which enables us to intercept requests made from the browser. And this is an important point. So the Playwright's route feature enables us to intercept requests made from the browser to our microservice, for example, with the items endpoint. And then we can tell it, instead of returning the real data returned by the service, we want to always return a list of those two items, for example. And this works fine, at least for single page applications, when we want to test applications that only run client-side JavaScript. But with server-side rendered applications, things are a little bit different. So here we can see an example, a very minimal example in a Next.js application, for example. So here we fetch the shopping list items from the endpoint of our shopping list of our items microservice, and this code runs server side. So this fetch request doesn't run in the browser at all, but only in a Node.js server or some serverless function, for example. And with the Playwright mocking feature that I showed you before, we can't intercept requests made from the Node.js backend or from the backend to our services, because Playwright can only intercept requests made from the browser. So mocking, at least using the Playwright feature, the Playwright request intercepting feature, isn't possible here. And the same is true for other server-side rendered frameworks like Nuxt.js, for example, as well. So in Next.js, this code can actually run both client-side and server-side, but the important thing is that it also runs server-side when we first request the page. And also with Nuxt.js, we can't intercept requests made from the server side. So this is a big problem for mocking, at least when we're working with server-side rendered frameworks like Next.js and Nuxt. But even worse, even if it weren't for this problem, which already makes it impossible, at least for some of the applications we build, there is another problem, and this is that mocks gonna lie. So let's imagine we run our simple test suite for our shopping list application, and everything is green, everything is fine. And now we want to make a change. Now we want to rename the name property, and we want to name it title, for example. So we make this decision and we change our mock data in the test, and also we change the implementation in our code base, and we go to the team that maintains the items microservice and tell them to make the change as well, and they agree, and maybe they even agree for a date. And yeah, so we think we are good to go. We run our tests, and our tests are green because we changed the mock data and we changed our own implementation. And at the agreed upon date, we deploy our application, and in production, everything falls apart because the microservices team didn't deploy the change on time. So there is still a name field, but no title field. And the important piece here is that with mock data, there is no way how we can automatically determine if our application will work in production or not. We only know that it works as long as the whatever is returned by the real service matches the fake mock data in our tests, but there is no guarantee that this is the case. So this is another big problem with mocking. So if end-to-end testing doesn't work and mocking doesn't work, what can we do instead? And what we can do instead is that we can use the techniques from contract testing, not only for improving the test coverage of our microservices, but also of our application. So with contract testing, we have, or with contract-driven microservices, let's call it that way, we have we have microservices that all agree on particular API specifications, for example, based on OpenAPI specifications. And the tests for the microservices and also the tests for our applications use those real API contracts instead of made up mock data that we only have in our application library, and it doesn't necessarily match any of the real specifications. So what this means is that whenever an API specification changes, this change is automatically picked up by our test suite and guarantees that the the test data we use in our tests matches the specification of the server of the service that's actually deployed somewhere on production. So this means that as long as all services and applications agree or use the same contracts or agree on the same contracts, all sides or both sides can be deployed independently. So how can this look like? For contract testing, there are two major tools that I know of. The first and probably most well-known tool is a tool called Pact, and Pact is a very mature tool for contract testing. But the tool that I like a little bit more is a rather new tool called Specmatic. And the reason why I like Specmatic so much for contract testing is that the contracts for Specmatic are based on OpenAPI specifications. And chances are, if you are already doing microservices, you probably already have OpenAPI specifications for all of your services. And if you don't, I highly recommend you create them. So with Specmatic, we can take an OpenAPI specification of a microservice and then use the information in the specification. Basically, we can see in there which endpoints there are and what endpoints, what data those endpoints expect, and what data they return when we call them with, or when we call a particular endpoint. So what Specmatic will do is that it looks at the OpenAPI specification and checks every endpoint and every HTTP method defined for each endpoint and makes a request according to the specification to our actual service, to the implementation of our service, and then checks the response if the response matches whatever is defined in the OpenAPI specification. And if everything works, then the contract test succeeds, and if not, then the contract isn't valid, and our contract test will fail. So, how can a contract look like? So, the minimal as a minimum, we have an OpenAPI specification which specifies how our microservice looks like, what endpoints we have, and what data it receives and returns. But we can also specify examples. So the OpenAPI the specification is in OpenAPI format, and the examples we can specify in JSON, or we can also use YAML, but I will use JSON in the following demo. And with those examples, we can provide information to other services how they are consumed by services and applications. So how can we go from end-to-end tests to application tests? And what is the difference? So we don't want to do end-to-end tests, and I also already explained why. What we want to do instead is doing application testing. What is the difference? So first of all, let's start with the similarities. So both end-to-end tests and application tests run in a real browser environment. Both interact with the application like a real user will do. So in both cases, we write tests that simulate how a real user will interact with our application. And also in the same way as for both, we test the entire application making real requests. So we don't do any mocking. We don't intercept any requests going out of our application. But unlike end-to-end tests, with application tests, we don't make calls to real services, but to a stub implementation of those services, but still via HTTP calls. So we are as close to the real thing as possible while still having control over the services that we depend on. Okay, so for the demo, I have prepared a little shopping list, which is a Next.js powered application. And with Next.js, we basically have a front-end part with components that are rendered both on the client as well as on the server. And we basically have a BFF, a backend for a front-end piece where we have server actions and server functions, and those server actions and server functions query data via HTTP from a shopping list service and from a rating service. And the shopping list service also makes requests to a product service behind the scenes. So obviously, this is very much over-engineered. So if you are building an application with this complexity, I highly recommend you don't go the microservices route. But, for this little demo, I wanted to keep things simple. So how does this setup work? We have for all of our applications and services for the shopping list app, the shopping list service, the rating service, and the product service, we have a shared contract repository. And all of those components of our system push and pull contracts to and from the contract repository. So the OpenAPI specs and examples. And then we can use the Specmatic stub server feature to pull all the contracts we need to power our shopping list application and start a stub server. And now, instead of making requests to the real services, now during testing, our shopping list application makes requests to this stub server. And first, I want to show you how the contract testing part of the whole thing works. So let's take a closer look at the shopping list service. or just so you know what we're talking about, a very short look at the actual application. So here we have our shopping list application where we can add new items and we can check off existing items. So this is the thing we want to test. And now let's take a look at the shopping list service, at the code. So for this, I have a mono repo prepared with an application and the 3 services. So let's take a closer look at the shopping list service. And in the shopping list service, I want to show you the OpenAPI specification of this service. So in the contract directory, we have this service shopping list YAML file. And in here, this is the OpenAPI specification. We have paths. So each endpoint is a path, for example, shopping list / items. And here we can specify the HTTP methods we want to support for this endpoint, like post and get in this case. And we can specify, for example, for a post request, how the request body should look like. In this case, it should look like this shopping list item request component, and what we expect as a response. In this case, for the post method, we expect a 201 code and a shopping list response of JSON structure. So let's take a look at how the shopping list item request, for example, looks. We have required fields, name and completed, and then we have properties like ID, product ID, name, quantity, and completed. And for the request implementation, we just specify that ID and product ID, for example, are required. So this is our OpenAPI specification, which also serves as a contract for this service. And what this enables us to do is to run a contract test. And the contract test works like that. First of all, we pull all the dependent contracts we need for testing. Then we build the application. We build a Docker image here. We start the Docker container and wait until it's started. When the Docker container of our application is started successfully, we seed the database with some data we need for the contract test to succeed. And then we run the contract test, and if everything is valid, we get this message. And this means our contract is valid. So we implemented everything according to the OpenAPI specification. But let's change this. Let's say we forgot to implement the items post endpoint, and we run the contract test again. So again, we build the latest versions from the contract repository, the latest versions of the dependency specs, in this case, the product service spec. We built the application now with the change we made. And now actually our contract test fails. And this is the output from Specmatic. Specmatic tells us that we expect to have a post, we have an items endpoint with a post method where we expect a 201 code response code, but we actually get 404 because we didn't implement it. So this is the basic functionality of contract testing for microservices. But what's more interesting to us actually is how we can test our applications. But before we move on, now typically, if we expect the test to succeed again, what we can do now is to push our contract to the contract repository. So we run the push command, and what this does is it pushes the contract to the contract repository, which in this case is just a directory in the file system. And here we see there is also this YAML file of our shopping list service. Okay, so we tested our service and we pushed the contract to the contract repository. what we can do next is pull the contract into our shopping list app. So let's go to the app, and in here we can pull the contract, and so we get first of all the shopping list YAML and also the rating YAML, because we also depend on this rating service as well. Okay, so now we have the latest version of those dependencies, and now we can use them to power our end-to-end test. So to start a stub server, which I already did. Here, here a stub server is running with a couple of examples, which we see now. So here I have the test file. Those tests are powered by Playwright, and then in those tests, you can see before we even load the application, we run this can add item function. This can add item function is what I call a precondition, and in this precondition, we can see we use a stub endpoint method, which basically is a helper method to configure our Specmatic stub server to return whatever we provide here. So we specify, and this now is an example file. In this examples file, we specify that we want, whenever we make a request to slash shopping list items with a post method and a body with a field name butter, we expect the following response, or we want the stub server to respond with the following data. But now that we have specified this, we can write our test where we can say we open the application, we fill in a new butter item, we click the add item button, and then we expect this item to be on the list. So let's run Playwright in UI mode. And we can see here, for example, the first test that we just saw in the code. Let's move things around a little bit. We can see our application here. We open it, and there is no butter yet. Then we add butter to our list, and then we have butter on our list. So this is this test, which now works with a stub server based on the OpenAPI specification of the real server, which is always in sync with the latest version deployed to production, at least when we run our CI system. And we have now an example that we can provide for the service again to use when for validating their contract. So now what we can do is we can push the shopping list app contract, which basically consists of the shopping list service examples and the rating service examples. But we now only saw the shopping list service, or one of the shopping list service examples. So let's close Playwright again and run contract push, which now pushes the examples to our contract repository. And what this enables us to do is a rather nice thing in our service again. So in the shopping list service, we can also run a command contract validate. This will tell us that for now our contract is valid. But when we go back to the service and, for example, we change something, for example, we decide we want to make the change that we saw in the slides. We want to change the name to title, for example. And now we validate our contract again. Then now it will tell us that we can't do this change. And it will tell us why we can't do this change, which is the interesting thing. It will tell us that in the app, in our app, we have an example, can toggle item completed, for example, and there we expect a name, which now is not in the contract anymore. Also in the have items example in our app, we expect a name, which is not in our contract anymore. So if you are the maintainer of the shopping list service, you now know exactly which other services and applications depend on a particular format or field in your contract. So now imagine the quantity field is deprecated for some time. So maybe you told all your consuming teams that you want to get rid of the quantity field, and but you can't be sure if they actually all removed it from their implementation. So let's remove it and run the validate command again. And now the validate command will tell us that our contract is still valid, although we made this seemingly breaking change, because actually none of the examples provided by our consumers, in this case the app, actually make use of this quantity field, so we are safe to remove it. So this is another benefit we get from this contract testing system. Okay, so to sum things up, what we've learned now is that mocking, when we use mocks, when we rely on mocks to test our applications, this creates false confidence, and we can't be sure if our application really works when we push it to production. So what this means, and another thing is that we should not use end-to-end testing with microservices, because with microservices we run into all sorts of problems when doing end-to-end testing. So last but not least, how can we avoid the problems with mocking and end-to-end testing? We can use contract-based stubs like we just saw to test our front-end applications, and this will also work with Next.js and Nuxt.js applications without any of the problems of mocking and end-to-end testing. Thank you very much.
Hey, welcome back. Thanks a lot for this talk. People definitely got a very detailed explanation and preview on how to use it. That's also what I like with your talks. It's usually show how it works, not only theory. So thanks again, Markus. Yeah, I'm not sure I can hear you. Can you speak again?
Thank you. Hello.
Yes, perfect. So a few questions. I like this one specifically. For new people with contract testing, what do you think would be the easiest way to start regarding Next.js or Nuxt?
I would recommend checking out, for example, the Specmatic documentation if you decide to go with Specmatic, which I highly recommend, but also if you decide to go with the more mature solution, which probably is packed like PACT,
Yeah.
then also check out their documentation. I think this is the best place to start, actually.
Yeah. Okay. Yeah, I saw one of your video 2 years ago or something where you spoke exactly about those, and those two indeed look like good solutions. Yeah, thanks. How do you handle versioning and breaking changes with contract testing?
So basically, they don't help you with your versioning strategy, which probably should be that you don't have versions if you're doing microservices, but opinions vary. But if you regularly have breaking changes, then they help you with um, being on top of them. So you actually will know that your application will break with a particular version. But yeah, they only can help you visualizing the breaks, and not really, not really help you with cleaning up the conflicts you will have.
Okay, so they don't really provide any more useful testing coverage as like other regular tests. It's actually even
You
harder,
will
I guess.
and they will break if you have breaking changes with a new version, but you still have to take care of them. So they don't really help you with easing the pain, I would say. They only help you, showing you that you have breaking changes that don't work with your version anymore.
Fair. Maybe last one. Do you have any selling point for teams that are a bit afraid of moving away from end to end?
Usually the pain with end-to-end testing is big enough so that many people are very motivated to move away from end-to-end testing and go more into the direction of contract testing. And I would say if you don't feel this pain, if you don't feel enough pain with end-to-end testing to feel very motivated to try something different, then maybe you're doing something right. Then maybe end-to-end testing actually is right for you. So then maybe don't use contract testing. So I think if there is a lot of pain, you probably are motivated to try something different anyway. And even if there isn't enough pain, then first of all, I like to hear how you do end-to-end testing because I'm really curious. And
I
second,
mean,
then
in my
maybe
case, I mostly have a QA team, so that's that's
yeah,
the solution. It's easy.
yeah. Then it's maybe maybe the right question to ask would be how much does it cost your company to
Yeah,
run the
in terms of
QA team?
employee, yeah, makes sense. Okay, perfect. Thanks a lot, Marcus. Thanks again for your
Thank you.
expertise, and talk to you very soon. Any last words?
No, thank you very much for inviting me and wish all of you a nice evening or whatever time of day it is